Okay, hello everyone. Good morning. All right. Yeah, okay, so hello everyone, and good to cool. Oh, I see, okay. Okay, yeah. Yeah, so good to see so many people here. So today what I wanted to talk about is just going back to some of the principles and values that make Ethereum what it is, and like why it's valuable, and also how those principles translate into some of the things that people who are actively building the Ethereum ecosystem are really thinking about, and I think it's important to continue thinking about today. So blockchains are a really valuable and just a really interesting kind of system, because they have these properties that I think are very unique, especially if you compare them to pretty much any kind of other technology that is being actively built and maintained over the last couple of decades, right? Blockchains are not controlled by any single individual. So Twitter controlled by a single individual, and a single individual can decide its name, can decide its policies, can decide to increase the cost of the API by a factor of like 10,000%. Blockchains are not controlled by a single corporation. So there's no single company that runs Bitcoin or runs Ethereum and has the ability to just change the rules at any time. Blockchains are not controlled by any single government. So not controlled by the US, not controlled by China, not controlled by Namibia. They're global systems that are intended to treat everyone around the world equally. And they're not controlled by any single political tribe, right? Blockchains are for everyone, including people that I disagree with. So I think this is something that's really valuable to remember and really valuable to think about, just because this is something that is true of so few other things that are being actively maintained for the last 10 years, right? Like centralized software that has been developed like basically for the last decade, even for the last 2 decades, tends to follow this model where there is one server controlled by one company, everything goes through that one server, everything goes through that one company, and it becomes this like central point of political power, and they end up changing their rules to increase their profits, to satisfy like the political goals of different people for all kinds of different reasons. And this often happens at the expense of the system's users, right? Like when even this year, Twitter made the change from allowing anyone to read tweets to requiring you to be logged in, and really like making the API much more expensive. Like that really ended up breaking a lot of applications that depended on Twitter, right? And so you cannot build around something like Twitter without just always having the risk that Twitter, the company, will just decide to flip a switch and make your entire business invalid. If you build on top of Facebook, then same thing, right? If you build on top of any centralized system, you're always vulnerable to the rules changing. If you use any kind of centralized system, you're always vulnerable to the rules of the system changing, the system deciding to exclude you. A lot of centralized systems just exclude many people around the world almost without thinking about it. So one recent example of this is if you want to be part of the community nodes, you need to sign up with a phone number, and the phone number needs to be from a, quote, trusted carrier. And I forget if it's still true now, but it was definitely true when I looked into this. They just arbitrarily decided that like one of the major carriers in India, like something like a few 100 million Indians, their phone carrier was not trusted, and so they could just not sign up for this, right? So a lot of these centralized systems, they just exclude entire large parts of the world because like they don't matter and the risk is not worth it, right? And blockchains are something that is global, or something that is open for anyone to read, open for anyone to use, and as an ecosystem should also be open for anyone to build inside. And these are properties of blockchains that I think are just really valuable to maintain and really valuable to build upon, just because like there isn't really any other tech sector that really is continuing to be international in the same way, right? There's a lot of splintering that's going on in the world over the last 5 or 10 years, and blockchains are one of the very few places where this is not happening. And so I think this is just something that is super important to keep in mind, and it's something that also really protects you as a user, right? Back. You know, as a user, if you are on a blockchain, any application that you create will not be shut down arbitrarily, right? You put an application on chain, that application stays on chain. Maybe like individual websites, like maybe Etherscan, decide to stop showing your application anymore, but it's still on chain, and you can just go to a different website. If being on a blockchain means your transaction will not be censored, even if an interface censors you, you can always switch to a different interface. You can always download your own node, run your own node, send the transaction by yourself, make your own interface with just HTML and JavaScript, share that with other people. Whenever someone excludes you in the Ethereum ecosystem, it's much easier to just go and route around that, because the thing that is not excluding you is the base layer. Being on the blockchain means the rules will not change on you at a moment's notice, and no one can just edit the database to steal or take away your money or your monkey, right? So, you know, if you have an NFT, you're keeping the NFT, it's yours. It doesn't depend on like some company's database to continue existing. And this makes it much easier to actually trust that a thing that you have actually will maintain its value. Now, these ideals do not just maintain themselves automatically, right? So this is a chart of the percent of MEV relays, which are a type of infrastructure that's involved in creating Ethereum blocks, that were censoring transactions, that were not allowing transactions from a few specific sources. And what we can see is the percent of relays that we're censoring went all the way up to about 75%. And fortunately, because of the way that blockchains are constructed, even if it's 75%, this just means that if you wanted to send one of these transactions, on average, you would just have to wait 4 blocks instead of waiting 1 block for it to be included. But even still, right, 75% is a little bit too high. And so there was a pretty concerted effort actually organized by the community, not organized by the Ethereum Foundation, not organized by any organization, just a big community effort, and a lot of people just really getting worried about this and pushing back. And the percent of blocks that were censoring transaction dropped from 75%, and now it's back down to about 30%, right? So maintaining the openness of blockchains is really something that often maintains this like very active community effort. Another thing that requires active community effort is preserving the system's decentralization, right? So here is a graph of different Ethereum clients, right? This is like different software implementations that implement the Ethereum protocol that different people use. And a type of decentralization that Ethereum really values is client diversity, having different portions of the network use different clients. Why does this matter? It matters because, one, it reduces the political power that any single developing team has, and two, it means that if one client has a bug, then that client breaking does not break the rest of the network. There are 2 types of clients in Ethereum. There are consensus clients, which manage the proof of stake part, and there are execution clients, which manage the EVM. So on the consensus client side, the situation is actually quite good. No single client has more than 50%. On the execution client side, things are currently not great. Geth still has more than 80%, but there are ongoing opportunities to really try to improve this, right? So if you look at the situation 2 years ago, Prism was actually at more than 75%. And now it decreased and it's now down to about 42. So this is something that I think can be done and needs to be done on the execution client side as well. One useful thing to compare this to is web browsers, right? So web browsers are, I think, aside from Ethereum, probably the most successful example of one of these multi-client ecosystems, right? So who here uses Google Chrome? Who here uses Firefox? Who here uses Safari? Microsoft Edge. So we have different browsers, right? Now, a lot of those are actually all forks of Chromium, right? But Firefox is not. And you have these different browsers, and their different browsers are like actually creating their own implementation of the same specification, right? So you have a separation between the process for agreeing on the rules and writing the code that implements the rules. And because of this, this reduces the level of influence that any one company, whether it's Google or Microsoft or someone else, can have on the rules of the internet. Now, it's not perfect, right? One reason why it's not perfect is because forks of Chromium, which is pushed primarily by Google, or have something like an 80% market share, right? But even still, Firefox also exists, and different forks of Chromium still are independently run things that are different, and so you do have this level of decentralization. If you do not have this, then you basically have an ecosystem where whoever writes the code can just choose what the rules are, and if they start having their own goals that are different from the goals of the wider community, then no one is really in a position to come in and replace them and be alternative developers. So trying really hard to make sure that that does not happen is one of the goals that the Ethereum community has, and a lot of progress has been made, but this is something where even more progress can be made as well. This is a geographic decentralization, right? So this is a map of Ethereum global node distribution. And you can see a lot of nodes in especially the East Coast US and like that part of the East Coast US that really stretches all the way up to include Toronto and Canada. And then, you have Europe, Western Europe especially. And then you have a bunch of, you have some smaller other centers, right? So you have a bunch of nodes in Singapore, some scattered across East Asia, some in various other countries. The top 7, US, Germany, UK, France, the Netherlands, Singapore, Australia. Would be amazing to see Turkey in the top 7 at some point soon. I think this is something that is absolutely in the power of any medium-sized country to do if you just organize your community and just have a really strong effort at making it easier for people to actually run Ethereum nodes. But this shows both the global dispersion of the Ethereum community, but also the Ethereum peer-to-peer network, right? So the more that this is distributed, the less the Ethereum network actually depends on any single one country, right? And if we want the Ethereum network to really continue to be this open and global thing that does not depend on what happens inside of any one particular country for its security, then improving the decentralization of this is also something that is a really important goal. So those are just like some simple examples, right? This is preserving the Ethereum network's ability to accept transactions from anyone, allow anyone to participate, minimize the extent to which it's controlled by one small group of people. These are things that really require a lot of active maintenance and a lot of active effort by the community. And the Ethereum community already has shown quite a lot of successes. But there's also like much more specific areas where we can look at. So let's look at, for example, account abstraction, right? So who here has heard of ERC 4337? Okay, amazing. ERC 4337 is a standard for account abstraction where the one-sentence summary is that if you have an account, instead of your account being controlled by a key, your account can be controlled by an EVM program, right? And that EVM program can implement whatever rules you want. You can have multiple keys, you can have a different signing algorithm, you can have a key where you can change the key, you can do all kinds of things. Account abstraction is super valuable for improving security because security is one of the really big challenges that I think really makes adoption of the Ethereum blockchain difficult for normal users, right? A lot of people, even if they have cryptocurrency, they're not using a blockchain. And a lot of the time, the reason why is because, well, the blockchain is not very friendly to use. There's two big reasons for this. One is scalability, the other is security, right? And I actually did the math at one point, and it turns out that like the amount of money that people lose to paying fees and the amount of money that people lose to getting hacked are like actually pretty similar, right? And so the two are, I think, to me, roughly equal problems, and it's really valuable to try to solve both of them. But it's valuable to solve security especially in a way that preserves decentralization, right? This is one of the things that I think is like super hard for the internet, and this is something where the traditional internet has really been failing at, right? So if we remember the internet 10 years ago, in a lot of ways it was really much more open, right? It's something where from most websites you can sign up anonymously, you don't need to log into accounts to do things, you can go see anything, you can go download anything, you could even write a script to go download things. And a lot of the internet more recently, like to sign up to something, you need to have a Google account, right? To even like look through like social media messages, you need to be logged in or you need to use some API that's super expensive. A lot of things like require you to like just either be logged in or have these extra proofs of some kind. And a lot of the time, the reason for this is basically security. It's like dealing with cyber attackers, people like just various other kinds of attackers, people trying to burn through your system's resources, people trying to do all kinds of bad things. But the solutions that people come up with by default are solutions that basically say, trust me, right? It's, this person is trusted because Google says that they are trusted. This person is trusted because they are from the US, which is a trusted country, and this other person is not trusted because they're from Namibia, which is not a trusted country, right? Like, this is the logic that a lot of these centralized systems often just have by default. And I think one of the things that Ethereum can do that is really valuable is try to create different forms of trust that are not centralizing in the same way and that can really reflect a much larger diversity of sources of information to try to determine like what transactions are and like what things are like good or what things are compatible with users' intent and users' wishes and what things are not. So ERC 4337 is sometimes criticized for being complex. And there's a lot of people who propose alternatives to ERC 4337 that are much simpler. So the problem is, though, that simpler alternatives to ERC 4337 generally have hidden trust assumptions. So let's look at the details of ERC 4337, right? One of the ways in which ERC 4337 is complex is that every transaction has two phases. There is the verify and pay phase, and then there is the execution phase, right? So first, you have this entry point contract that calls every single account and makes sure that the account actually can pay. Then you have the phase where the entry point contract calls every single account and actually performs the operation. And you have a lot of this complexity to manage the safety of the verifying and paying mechanism. And so a lot of people wonder, well, why do you have to do this? A big reason why we have to do this is to ensure that what's called a public mempool is possible. What a public mempool means is you as a user can send transactions, and you send a transaction straight onto a public network. And then the transaction just automatically gets broadcasted, and then someone accepts it. You do not have to send your transaction to some trusted provider. A lot of these alternatives to ERC 4337 that are simpler, they depend on trusted providers. Now, why do they depend on trusted providers? Well, suppose that I send a transaction where that transaction looks like it pays the transaction fee. But first, it does like 5 million gas of computation. It does a bunch of really complicated stuff. And then at the end, it turns out it doesn't actually pay the fee. Or it pays the fee at the beginning, but then at the end, it does a revert, and so the entire thing is invalid, right? In order to prevent the system from being broken to those types of transactions, basically, you will inevitably need to have a kind of traditional trust architecture, right? Basically, what that means is that you'd have to have trusted gateways, and those trusted gateways would have to trust users, and then if users start abusing the system, they're going to start demanding that users log in. They'll start checking, oh, what country does this user's IP come from? If their IP is a VPN, then that user is going to get blocked, and like doing the kinds of things that people do in the existing internet. And this ends up like basically destroying the openness of the system, right? And so really preserving the kind of extremely open, but at the same time secure approach that the existing mempool gives you, where you as a user can send a transaction, and everyone is willing to rebroadcast and include the transaction because they can just look at the transaction and they know that it's going to pay the fee, and so it's not trying to cheat the miner, and they can see that just by looking at what it is. Just by looking at like basic details of the transaction and of the account that sent it. ERC-437 is trying to replicate that basic property, but for account abstraction, right? So having security and preserving openness at the same time. And if you do not understand that this is your goal, then you're going to invent something which accidentally either forgets about security or forgets about openness as a goal, and you'll end up like basically really reducing the security of Ethereum from the point of, and reducing the openness of Ethereum from the point of view of its actual users. Openness in cross-layer 2 swaps. So who here has done a swap like between one layer to move assets from one layer 2 to another layer 2? So chances are you did this by using what, like some protocol, right? Could be like hop protocol, could be like, like one of those. There's a bunch of these like proprietary bridge protocols, and a lot of the time these bridge protocols depend on one central actor to be online to continue working. This is something that's like okay for now, but this is not something that we want to depend on in an ecosystem where users need to have the ability to just move from one layer 2 to another layer 2, just because you just have to do that to perform any basic operation. And so there are better alternatives. So this diagram is from the Uniswap X paper. This is a project that is being worked on by Uniswap people, basically an open standard for how users can submit orders that basically say, I have coins on Arbitrum, I want to trade them for these coins on Optimism, and I'm willing to pay fees. And other people can then come in and fill in that trade. Open protocol does not depend on any single centralized party, does not depend on any point of trust. To submit a trade, you do not have to choose who to trust, you do not have to be trusted, and the whole thing actually works in this completely open way. So, right, so open standards. So ERC 1271, extending signatures to the world where users can have account abstracted accounts. There are open standards for this. Some applications support them, some applications do not support them. Applications should support them. ERC 4337, account abstraction. ERC 6900, modular wallets. So that different people working on wallets can work on different pieces, and wallets can share code as much as possible. The more wallets share code, the less total code you have to write, and the more secure we can make the code that gets written. So if we work together as an ecosystem and if we follow standards, then we can have more security and better ease for wallet developers. ENS. A lot of applications use ENS. Other applications try to roll their own name system. Generally, rolling your own name system is bad. Use ENS. ERC 3668, CCIP, right? So this is a standard by which things like ENS can live on layer 2s in a way that still preserves decentralization. So this is another example of a standard, and it's something that's really powerful that you can build on top of. So lots of these standards exist, and there's a lot of these open things that you can build on. And so the thing that I would encourage people who are developers in the Ethereum ecosystem to think about is like basically build tools, not empires, right? Like, I think the standard dogma in a lot of startup world is like, you wants to build an empire, right? It's like, you know, you have Twitter, and like, you wants to bring the entire world into Twitter, and like, you want to like penalize by 100x accounts that contain like links because you don't want people to link to the outside world, you want people to stay in Twitter. Like, this style of thinking of like trying to create your own ecosystem and trying to dominate is like, to me, the opposite of what Ethereum and what other blockchain ecosystems are trying to do, right? To me, the spirit that is going to succeed is the spirit where you think of what you're building as a tool, and you try to collaborate with both the standards that already exist and the standards that are being created today that will exist in the future, so that you can be a piece that other people can use at the same time as using other tools that other people are building in the community. And so this way we can have the network effects of a large ecosystem without having everything be under a large company. So this is something that where there's a large ecosystem of people that's working hard on building and implementing these things, right? So you have the roll-up improvement proposal ecosystem, a very recent RIPs to try to coordinate upgrades across different layer 2s. You have ERCs, some of the open standards that I mentioned, EIPs for changing the protocol rules of Ethereum itself, and this is something that's really important, especially as Ethereum goes through this rapid transition to switch to layer 2s, improve security, improve privacy, and improve scalability at the same time, right? And my big hope is that as we do all of these things, we still maintain and we don't lose the spirit that really has made the Ethereum be the blockchain that it is today. And so I hope that you know, everyone here can remember that and continue to be a part of making that happen.